Hi, I'm David with General Air. Copper-coated gas-shielded flux cord wires are really nothing new. They've been around for a while. But why? Now, I understand with an ER70S6 wire why you'd want to put a copper coating. It's going to help the electrons jump from the wire to the contact tip. And really the same thing is happening here with the copper-coated gas-shielded flux core. However, there's a little bit more to the story. These two wires are the same classification, an E71T1. Now, the big difference that I see between the two is their hydrogen content. The Fabco 777 is an H8 product. That means there's 8 milliliters of hydrogen per 100 grams of weld metal. And the MEGAFIL 713R, which is also a Hobart product, is an H4, so half the amount of hydrogen in the weld material. And a lot of times what I see on these spec sheets when you look at the actual values is they're lower than an H4. You'll see like H2.3. Now, they can't advertise that because the lowest that the codes or the classifications will have you go is an H4, but these can be very, very dry wires. So if you have a tightly controlled hydrogen program at your industrial shop, then a copper-coated wire might be the choice for you. Now, my biggest question is, do they weld any different? I understand the seamless advantages and not letting that moisture get in there versus this has an open seam to it. That's what I want to do in this video is I want to weld with the 777 and the MEGAFIL at the exact same parameters, see what their amps and voltage is, what their nominal amps and voltage is as I'm welding, and then really talk about the weld characteristics. Does the copper coated weld better than the seamed non-copper coated? Let's check it out. All right, I'm starting off with the 777, the Hobart product, running 415 inches per minute and 26 volts. And we're in DC electrode positive. I am running a 75-25 argon CO2. I'm going to run about 45 CFH. And then I'm just going to run a vertical up here, take a look at what the amps and volt values are when I'm done, because my machine's going to be able to record that. Here we go. All right, I'm trying to maintain a 1-inch contact tip to work distance. So far, yeah, really nice, smooth T1 wire. And what you really want to look at is right at the end of the wire, some of the lower quality ones, you'll start to see them split open right before the wire hits into the arc. And then that can cause some globular transfer. Definitely not the case here with this 777. It is really nice and buttery smooth. I can see a little bit within the arc. I can see that the stream of metal is not quite axial. It does drift off into one direction. See if that changes at all when we go to the MEGAFIL 713R. Super easy slag removal. Like any dual shield wire, you just touch the slag and it falls right off. Very minimal spatter. There are a few BBs. As to be expected on some mill scaled up plate. Now my average amperage, it was 234 amps, and I really only lost 1/10 of a volt, so 25.9, which is completely acceptable. Let's switch over to the MEGAFIL 713R and take a look. All right, the MEGAFIL 713R. Right off the bat, I can tell the puddle is a lot more fluid. I do have the exact same parameters like I did with the 777, but yeah, definitely a much more consistent spray across the arc. I could tell for sure that the filler material and the slag are both just pinching down really nicely and going right into the center of my puddle. I can see a lot better control over the toes of my weld. The 777 got a little bit wide in the middle, and that's fine. But yeah, this one has got a lot of control to it. You can really see at the edge of the wire, it pinches down really nicely and just sprays super smooth through the arc. be interesting to see what the slag removal is like. Let's take a look at the slag removal process with this guy. And as per usual, the slag just pops right off with a T1 wire. The average amperage for the 713R was 253 amps, 25.8 volts, so I lost another tenth of a volt, which is no big deal. But man, that jump in amperage, that's pretty surprising. It's a 19 amp jump at the same exact wire feed speed and contact tip to work distance. So I'm thinking there, of course, with that copper coating, you're just able to get more electrons out of the material, and that gives you more amperage. Now I can see there is significantly more spatter with the MEGAFIL than there was with the 777. It's a lot more of like a fine mist spatter all around the weld bead. Consistency of the weld bead, and there's a little bit of inconsistency, but that's more my hand than anything. And then right at the top, there is a little pinhole that I didn't get with the 777. Now that also could be because I didn't pull the mill scale off of the plate, but just something interesting to note. So when is a copper-coated seamless wire right for your fab shop? Well, if you have a strict hydrogen control protocol, building a bridge or something that hydrogen-induced cracking is definitely a concern, then the nature of the low atmospheric absorption of these types of wires and the H4 designation that it gets is definitely worth the premium that you're going to pay for the wire. Now the operational aspect of it and how the welders look at it is definitely a factor too. If you've got a welder that likes a really stiff arc, a really easily manipulated puddle out of position, shoot, hand them a roll of the MEGAFIL, the copper-coated seamless wire, and I bet they're really going to like it. If you're welding a lot of in-position stuff and fluidity really is the key there, and you don't really care about the operator appeal, yeah, save the money and go with the seamed non-copper-coated. Thanks so much for watching. If you're interested in general air or anything that we do, check out our website linked in the description.